Live from the Icebox Studio in Montgomeryville, Pennsylvania, it's the Bill and Corey Show.
I'm Bill.
And I'm Corey.
Welcome back. Today is live episode number 70.
Wow.
Man,
too bad it wasn't the 80th episode.
Well, I know. It kind of coincides with the 80th anniversary of D-Day. And I was chatting with one of our quality people here. He's in the quality department, not just a quality person, but a quality person. He's mentioned about something about, you should have something from, Matheson's been around that long. And, Matheson, that we invented spec gas back in 1927. Adam Matheson started.
Before that, there were no gases.
There weren't special ones.
Oh, so they weren't special. Everybody was the same.
Everybody was the same. Now we have the special ones. Now everything's special, so nothing's special.
Oh, that's how it goes.
It just kind of dawned on me. We have stuff from then.
Wow.
This is a price list.
I had paper back then.
From 1944.
Wow.
This is not D-Day edition, but this is sent out in March.
Come on, you got to give us some details. How cheap was stuff back then?
Oh, yeah. We got, these prices no longer valid.
Disclaimer.
Ammonia in a 1A cylinder was $18.
Wow.
See. And argon was, $57.60. Wow, that's pretty expensive.
Well, you know what? I'm sure
it's probably gone down.
No. Well, I'm sure some prices in this would seem low because inflation and stuff.
Inflation.
But the economies of scale for the future would possibly push some prices down. Like it's probably easier to get argon these days than it was back then.
You don't have to pick it from the argon tree.
No, you don't have to pick it.
You got membrane.
Now you can just suck it right out of the air.
Yeah, you just get it right out of the air.
But I have a pertinent question about D-Day. Bill, what happened to A, B, and C days? Did they skip those? Did they what?
Yeah,
you said you couldn't make a D-Day joke, and I proved you wrong.
You haven't proved me wrong. But it does have. They didn't call pressure regulators back then. It was reducing. Want to zoom in on this one? You can. Yeah, it's not. Reducing valve number 1. So it's the. So they
call the valves.
They call the valves.
So when somebody calls my phone and says my valve's not working, they're from the 40s.
Yeah, I know.
Time travelers,
really
if you will.
Pressure regulator. So that's I guess that would be like the Model 1.
That's the first one. At least they stuck with the first one. Now we're on number 3800.
They went to 1A.
Now we're up to 3810. So there's been 3800 different regulators since then.
But some is the Model 50.
Ooh.
That's pretty much hasn't changed much at all. But what can you do? It's got a CGA fitting.
Broke,
it's got a valve.
fix it.
Different handle now.
Probably diaphragm.
And
what was the technology back then for regulating? I wonder did they use diaphragms or they use pistons? Which was?
This is all brass nickel plated. Control is used for bubbling gases into a beaker for use of oxygen, nitrogen, hydrogen, carbon dioxide, and hydrogen sulfide. If you get the 51 is made of cold rolled steel.
Don't do that anymore.
No. Yeah. So.
Sounds so.
That's it. So, anyways, that's old stuff. That's not some of our technical questions.
I don't know why, but whenever somebody says cold rolled steel, it sounds tough.
It really does. Okay, actually, our first question.
Now on to the questions.
Now we'll get on to the questions. Well, that's kind of fun to look at.
Oh, yeah.
Oh, actually, this one's another old one. Not back from there. So we occasionally get emails with photos or images in there.
We actually prefer, if you can send an email, just attach pictures of your setup every time. That would actually be a good thing.
That helps a lot.
It helps a lot.
Sometimes they say, hey, my valve isn't working. And it takes 3 emails to find out it's a regulator.
Sometimes that happens.
They're speaking old. So you want to toss up the first graphic. This is a rotameter.
You can say old.
And they want to be able to identify this.
And we identified it as a rotameter. We did it. We did it.
They want to reorder this thing
now,
again.
this is not the best picture.
No.
It's from the side.
Okay, you want to put up the next graphic. That's straight on. And you look at that and you go, yikes.
Nice clear tube. You can read it easily.
You expect it to say Matheson, Rutherford, New Jersey on it or something like that.
Well, it's even got the new logo. So it's a newer one,
too.
Yeah,
so you look at this, you go, yikes. But you have to dig in a little bit. You want to go to the next graphic. So we could tell from this it's an FM 1050 frame by the length and that it's black. And then I look at a couple things. I looked at the upper right-hand corner of the valve, and it looks like the nut came off of that, and that's like the insert inside the nut. The knob of the valve. Yeah, so the plastic knob, it looks like that got knocked off.
They replaced it with
and that's the insert. Yeah. That's the insert of the.
Oh, I see what you said. Okay,
That's my guess. Either that or they found some knurled thing to put in there. And then you look at the panel nut too, and that tells me a little bit about the fitting. So yeah, I can learn a lot just by looking at that. So you want to? Oh,
doesn't it look like the other side's a little bit bigger though than the one on this, like the out.
Yeah, you look at that and it's like, yeah, I don't know. But the nuts tell you a lot. So you want to go to the camera? Okay, and I'm going to zoom in a little bit. So this nut, we have two different we have different outlet fittings. But this nut is kind of like a real nut. Nothing against the pals. But this is only used on our 1/4-inch fittings because it's big. And for the other ones we use, this is called a pal nut. It's just a stamped piece of sheet metal.
Yeah,
and it's inexpensive. And these nuts really aren't.
They're not really nuts either. Yeah.
Really not, and they're really not used that much. But this does the trick for what
it holds it.
It holds it into place.
That's all you need.
Yeah, it's a lot less expensive. It's more cost effective.
There you go. That's a good buzzword.
Now, the only issue is, keep zooming in, is that there was, we'll blame it on COVID. So we had issues getting this kind of, you're like, geez, these things come in the millions, the PAL nuts. So for a while, we had to go with this nut for that size. And that's hunk and fat. So it's a lot fatter. But you can tell by, I can tell by looking at it, it's this nut. Okay, so we knew that it's a 1/4-inch female pipe thread in and out. If it used a PAL nut, it could have been 1/8 in and out, compression fitting in and out, or hose bar.
There you go.
So yeah, all the mess stuff on there kind of confuses you. So let's go to, and we're going to talk about valves. So looking at the valves, you want to zoom in again? I'm not good at this. The shorter valve is utility valve, and the longer one is the HA valve.
The high accuracy valve.
High accuracy valve, right?
This one, I don't really want to use acronyms if we can help it.
And acronyms.
And acronyms.
So it's a higher stem. It's a non-rotating. It has 15 turns in it. It's a little more fancy, more expensive, more accurate. And we have a video on the difference between these valves.
They do. Yes, there is.
It's not just the height. It's on flow control and stuff.
Do you want a taller valve?
Yeah, it's like, you want a taller valve, you want a short valve. Take your pick.
What's the difference?
So by looking at it, we could see that valve, even though it was missing the handle, and the handles are labeled. We got HA on the high accuracy valve, and this just says high. So we have medium, low, high, and it has
high flow.
7, 8, 9.
Yeah, it's the different valves for the flow rates.
1 through 5, 6 maybe.
I thought there was 6.
Yeah, the production tech's gonna yell at me for not knowing it, but that's kind of it on that. So you want to get back to the next graphic? Now this is the scale. So we had someone with really good eyes, and you could actually zoom in a little bit more, but it went through. So that looks like we knew it was nitrogen.
Well, you zoomed in and then enhanced, right?
No,
like in CSI when they can magically do that with pictures.
It could have done that, but it could have come up with something, picture of a monkey head or something.
That's
like
true.
That. Yeah. But yeah, so that looks like a 25, and the other one looks like a 30 near the top. So we had one of our sales specialists, customer service, inside sales specialists, take a look at we have a list of the scales that we use that are available, and look through that. For
tens of thousands, it feels like.
It's probably more than I can count. But Ed found a 30, one with nitrate. I think it was SCFH.
Oh, SCFH.
Like that. So we did find a scale for that.
And what's interesting about this one, though, it's a 1052, but it's not a reference scale, right?
Yeah, a lot of times. Yeah. A lot of times they're millimeter millimeter scales, then you have a reference chart that goes with
But
it.
on our online store, if you buy 1050, they're only reference charts. You have to go to our.
There are a few.
Oh, there are a few. Oh, they're only
for a hydrogen cooling system. But
okay.
We'd like to expand that offering, but we haven't gotten to that yet. So that's really it for that question.
Yeah,
so,
we figured it out, or Bill figured it out.
yeah,
I didn't help
figured it
actually.
out, or something close enough. Okay, now we're still doing FM 1050 questions. So the design, this question from a customer says the design features for the FM 1050 says low pressure drop for increased available flow rates at low feed pressures. And they want to know, what does that practically mean? Is the pressure drop negligible? Or is there some data that you can provide? So this one's for Corey.
Yeah, no, unfortunately there's no data we can provide, but the pressure drop is negligible. It could be a few inches of water column, which 28 inches of water column is 1 psi, and this could be about 3 inches, which is about 1/10 of a psi. So you're looking at really negligible. Yeah, I mean.
Well, I just used a 3-inch up there. They just say it could be a few inches of water column.
Yeah.
I just wanted people to give reference that 3 inches of water column.
Oh yeah.
Is 1/10 of a psi.
Because it's not a normal measurement we use.
Yeah.
Well, we use it normally, but people in general don't know what it
Yeah.
is.
So it'd be really hard to tell on your.
And what is a water column? You know, it's like if you had a column of water just fall to the floor.
Yeah, it's the pressure
it just fall to the floor
from the water. So. Okay. Now we're done with rotometers for today. The customer says, I'm looking at the flash arrestor SEQ 6104BF for flammable, and the SEQ 104BO, that's for oxygen.
Flash arrestors, aren't those the policemen in Central Park? Isn't that what they do?
Could be. Does that qualify as a joke? Tune in next week. And the person says, we, that's them, not us, are required to perform flow calculations for the installed condition. Can you please provide the flow curve pressure drop data associated with these flash arrestors? At first I was a little shocked. It's like, oh, we must have that already in the online store. But nope, not yet. We'll have it
post-haste.
Post-haste. So you want to pop up the next graphic.
And look, we have a lovely, lovely logarithmic scale for our flow curves. As you can see, there's 2 logarithmic scales on there. The first one.
Yeah, there is.
Okay.
Well, it does. You look at that and you go, what the
Yeah, well, when I
heck is
first
going
looked at it,
on?
I had to make odds and ends about why is it there? Why is it there? The first one is for acetylene because, as you can see, it only goes up to 1.5 bar, which is
22 psi.
22 psi.
So one bar, acetylene you want to use.
Yeah, 1 bar is atmospheric, 14.7. Or 14.5.
The metric guys.
It's the metric guys. I'm sorry. Yes, I misspoke.
So 1.5 would be 22. So that's like for the acetylene guys. Yep.
And then you can see on the side the scale 0 to 22 of normal meters cubes per hour.
The numbers on the bottom, say 1.
And as you can see, even though they could, in my opinion, they could have just like separated a little bit more, but I guess they did. But then it goes to 1.5, and then to 2 to 3, and then as logarithmic scales, if you know how they work, they just just to make the graph smoother. Essentially, they do. I can't remember exactly off the top of my head.
Just it makes it easier to read the data.
It does.
Because if you took away a logarithmic,
it would be jumps.
It would be jumping. It'd be kind of more severe.
Yeah.
And then it'd be hard to differentiate between. Even the 1 and 1.5. It'd be so close, and it'd be like, I don't know what that is.
So in this case, the graph on the right is for the other, the methane, the propane, the oxygen, the hydrogen. Even though it can't go up to 30 bar, it tracks it that high.
Well, some of the oxygen can go up close to that.
I mean, it just covers it all.
Yeah, it just.
And as you can see, the graph on that side going up is 0 to 330. That's normal meters cubed per hour, which is way higher than the acetylene, obviously.
Yes.
So that's the differences in those scales.
And if you tried to put it in one scale, it'd be just.
It would be, yeah.
If you think of it, it would just be big, and it would take a couple pages.
It would.
Split it up that way.
So yeah. So there you go. Flow.
Okay, now back to here. We're gonna run a little bit later than normal today.
Or we have. Never mind.
Well, we got to do this one.
Okay.
It's not a
Corey
show thing, not a leftovers question. So someone was asking about the SEQ 633106 gauge, pressure gauge. Is this used for acetylene? So this is you want to zoom in on this? This is a typical brass acetylene gauge, and you see it's got a red zone in there, and that's for danger.
Like your defense in football, red zone's danger. You don't want to be in the red zone. Well, you want to be in your opponent's red. I never know. Red
Defense
zone
doesn't want to.
Typically not be in the red zone. Yeah.
Not really related. I think
No,
this
it's
gauge
not.
came before the whole red zone thing.
You think so?
Red zone is.
It's also a great channel, the red zone.
Oh, I can't follow that because it's just like.
I love it.
Highlight.
I love it.
You have to like what? So yeah, so that means you don't want to go above with acetylene. You don't want to go 15 psi because it could go boom.
Yep.
Go boom. So, as my old boss would say, that would be bad. Yeah, so that's acetylene gauges have that little red zone to tell you.
And we used to run our infrastructure on acetylene.
Acetylene
lights.
Acetylene lights in here. That was back in even.
That was before D-Day.
D-Day.
That was before D-Day.
Yikes. Well, that's all the questions we're going to cover today for the Bill and Corey show. Tune in again next week for another live edition.
Set your VCRs.